So in this question we are given that a tank is filled with gasoline to a depth of exactly 2 feet. And let's read how the tank is. It's a cylindrical tank which is resting horizontally on its side with its circular ends oriented vertically. So we have a figure something like this. Okay, and this is the height till which gasoline is filled, and this is 2 feet. We also know that the inside of the tank is exactly 6 feet long. So this is basically the height of the cylinder. We have to find the volume of gasoline in the tank. Now we don't know the diameter of this cylinder, right? We know the height, we don't know the diameter, and to find the volume of the gasoline inside the cylinder we need to know the diameter or the radius of the cylinder. Okay, so step 1, let's just write down that the height, or it's better if we use the word length here, because the height we will be referring that to for the gasoline. So length of the cylinder is equal to 6 feet and the height of gasoline, this is given to be 2 feet. Now we have to find the volume of gasoline, and like we discussed, we need to know the radius or the diameter of the cylinder to be able to find the volume of the gasoline. Now let's move on to step 2 and analyze the statement 1. The statement 1 tells me that the inside of the tank is exactly 4 feet in diameter. Now this directly gives me the diameter, which is 4. I can find the radius, which is 2. And if you notice that the radius is 2, which is also equal to the height of gasoline. So this implies that the gasoline is filled exactly half of the volume of the cylinder. Okay, so volume of gasoline will be equal to the volume of the cylinder, which is pi r square h by 2. We know the value of r is 2, h is 6. So it's a DS question. I'm not going to calculate the values because I know that I can find the volume of the gasoline using the information given in statement 1. So statement 1 is definitely sufficient, and out of the given options I will eliminate answer option B, C and E. Now let's move on to statement 2. So the statement 2 here is a bit tricky in the sense sometimes some students might end up faltering here and they mark statement 2 not sufficient because it is just giving you the area. Now how do they have to analyze this? Okay, so the information that is given that the top surface of the gasoline forms a rectangle that has an area of 24 square feet. So this is the rectangle that we are talking about. And if I take a separate diagram for this, I would have something like this. So this is the slanting surface of the gasoline and this is a rectangle. So let me just straighten this up and we get a rectangle. So this area, this is equal to 24, and I know that the length is 6. So I can find the width. So length times breadth is equal to 24, which gives me breadth is equal to 4. So this length is equal to 4. Now I don't know the diameter here. In this case, the diameter is unknown to me. So what should we do? Let us examine the cross section of the cylinder. So if this is the cylinder and this is the length 4, okay, and this is the radius of the cylinder, and this will also be the radius. So we know that this length is going to be 2 since this is the height of the gasoline and this is also going to be 2. Now if we take the distance from the center to this chord as x, okay, the radius would be x plus 2. So this length here is also equal to x plus 2, and we know that the radius and the chord makes a 90-degree angle. So let's check for what value of x would we have, can we find the volume of gasoline inside the cylinder. So since this is a right angle triangle, I can apply the Pythagoras theorem. So I would have x plus 2 whole squared equals x squared plus 2 squared. Now on simplifying, let me just draw a straight line here to demarcate the area. So I have x squared plus 4 plus 4x equals x squared plus 4. Now if you notice, x squared and x squared gets cancelled and 4 also gets cancelled. So this leaves me with 4x equals 0. Now 4 is a constant, it cannot be equal to 0. So this definitely implies that x is equal to 0. So initially the radius that we had taken was x plus 2. And since the value of x is 0, the radius is equal to 2. Now we have arrived at the same information that we got in statement 1, that the radius is equal to 2. And here as well, the volume of gasoline will be equal to pi r squared h by 2, half the volume of the cylinder, since 2 is the radius of the cylinder and the height till which the gasoline is filled is also 2. So statement 2 is also sufficient, and thus the correct answer is option D.